Hi there, and welcome to my submission for C++ games programming Cybernetic, a sci-fi themed top-down shooter programmed in C++ Visual Studio Code. The game has been downscaled from the original pitch I made due to scope concerns and my inability to program specific features I would have wanted within a time frame, so the game is as follows. As the player, you must fire off 10 bullets in order to win, while avoiding the robots guarding the area. If you manage to do that, you win. If not, then you lose. Let's start by going over each feature I have in accordance to the mark scheme. First off, we have basic character movement, allowing smooth movement using the arrow keys via the use of key states pulled from this enum here. These are calculated in the game loop every frame update. Additionally, the player is unable to go over the edge of the screen as they collide with the edge. Note that hitting the wall is also grounds for a game over screen to further encourage avoiding the edge of the play area. The player has a custom sprite using a sprite generator online that you can find here and in the README file. Next up is shooting. To save on memory, every bullet will despawn after exceeding the limits of the screen. Right here at the top, you can actually see the exact moment the bullet hits this limit and disappears. The bullet itself is only spawned when you press down on the spacebar again to combat memory-related issues that I'll get onto later. I have added in a shooting delay so that one bullet will appear at a time. If you notice on screen, if the delay is shortened to say no delay, an egregious amount of bullets will otherwise be spawned, which would be hellish in memory. Also, a ping sound effect plays when you shoot your gun. This sound effect is reused from my web game. This is played through the WAV channel, making use of the SDL Mixer library. This is also the case with the background music heard in the intro, except this is played through the MP3 channel using the same libraries. Next up, we have the enemies, of which 5 instances of them are created when you start the game up and are spawned at random locations across the map. All 5 of these have boxed collisions with the player, and upon colliding with them, you will lose your life and the game will be considered a loss. On that note, since the game is full screen, you'll need to use Alt F4 to exit when you lose, or win. But that being said, if the size was smaller, the X button would work just as fine at the top right of the screen. That leads nicely onto the user interface. 2 different font renderers are used, one for a score and one for health. The variables used to display these are located in the player class. SDLTFF is used in order to do this. In addition to numerical values, a sprite of a heart is on the screen, acting as a sort of health bar for you. When you lose, the heart will disappear to indicate a death, as well as the health font renderer displaying a you lose message. If you are to win, then the score will display a you win message. On collision, the health will decrease, and when you shoot, the score will increase by 1 every time. Next up is a tile map read from an external file, which is a text file located in the assets folder, and read upon initialization of the game. This displays the map of the backdrop of the game. There are currently no collisions with the tile map because I wanted the player to move around the map for reasons I'll explain a little bit later. When you lose, notice a second tile map displayed on the background, stored in a second file that replaces the background with one of these plain tiles to indicate the game is over. A binary file could have potentially been used, but writing the tiles in the text file is much easier. The change in tile maps can only be caused by player actions that cause a lost condition. So that's it for the features, so feel free to look deeper into the code to dissect a little further into how they work. Now I want to talk a little about performance. The main method of memory management I used in regards to the bullets, only spawning when needed and ensuring that they despawn so that none of them are still processed by the program when they fly off the screen. Then I conducted 3 tests using the diagnostics window within Visual Studios to check for any memory leaks. Now, I won't lie, I was a little spooked when I started the first test, seeing this jump from the high 60 to 78, thinking it would keep going exponentially. But this leap can be put down to a few things, with the main one being the loading of all the individual assets. I have a lot of these. These range from PNGs to different fonts, and the largest ones being the music files used in the background of the game. In subsequent testing runs, as you can see on screen right now, the memory does only do this leap in the first few seconds of gameplay as it is loading everything further, adding to my theory. So with that, it'll stabilize around 77 to 79, which is perfectly fine for the running of this game and runs very smoothly on most machines. As for CPU usage, not much is being used at all, but that is down to the program being very small. I'm sure if I added a lot more, it would become a lot more intensive. The second aspect I had to consider was my actual code. See, for detecting collision between players and enemies, I handle this in the update function, with the variables that hold the rects of each object being updated every frame, and the if statement being checked as this happens. The actual running of this code does not impact performance too much, however. It is worth noting that when you actually collide with an enemy, the total memory usage will decrease as none of the enemies are being rendered anymore, so it is fair to say that they have an impact on performance, just not a massive one that is detrimental to the game. The update function itself takes a while, taking around 100 milliseconds between each update call, which isn't optimal. To mitigate this in the future, I would probably want to handle collisions elsewhere. However, I feel that no matter where I put it in, a similar performance hit will occur as a result of trying to check every frame if they collide. Another final performance comment I want to make is regards to the initialize function within the game loop. As you can see, I initialize 5 different enemies, all derived from the same class. This definitely impacts performance, as each of these will need to call essentially the same functions every time. Now, in a scrapped enemy script you can see here, I was attempting to devise a solution. The solution in question was to essentially render a copy of an enemy 5 times while only ever initializing one instance of the enemy. However, while that plan obviously didn't pan out, I think the remnants of this code demonstrates I have at least considered the ramifications this has had on performance. One final topic I want to discuss and justify is the structure within my code itself. While a lot of important aspects of the game, such as collision and key detection, is handled in the game loop script, I've still tried my best to deconstruct each significant area of code into its own script. For example, the health, font renderer, and the health sprite are in 2 different scripts. This allows me to call one separately on the occasion different conditions within my code are met. The same goes for the tile map, but in this case it was less out of concern of performance and more out of not really wanting either tile map to risk conflicting with each other. However, there is one point I do think could have improved on, and that is my bullets. While they work as I intended, I still feel I could have gotten more out of the object pooling by putting them in their own separate script, which would just further remove them from the player, which would definitely have helped with detecting collisions. While I have met many of the criteria in this project, there are a few things I wanted to implement but haven't had time due to time constraints. For example, you'll notice that firing 10 shots to get the victory isn't very difficult. This was because I wanted the enemies to be able to pathfind to the player's location, which would have helped with adding a sense of urgency to the game. This is partly why I didn't introduce a collision into the tile map itself, because I was concerned that when implemented and the enemies are moving, the game would not feel as fun, as it would definitely be very easy to get boxed in by 5 enemies all at once. That's not to say no performance increases have been gained throughout my project. You see, in regards to the enemies, when you collide, there is code that just eliminates that enemy and not the other. So let's say we increase the health from the 1 in the base game to, 20,000, let's say. When you hit the enemy, only that enemy is gone, and you can see in the performance metrics that that means there is a decrease in memory usage, which again will just further increase the performance of the game, which, let's say this is a full-scale game, will allow me to spawn in more enemies without costing too much more memory, because 1 can just simply replace the 1 that has just been destroyed. Now, while these aren't the biggest performance increase in the world, these small kind of adjustments, if this game were to get bigger, would save a lot on memory. So I hope you can at least see where I've tried to optimize my code where I think it counts, and the attempts, even if they haven't made it in the game, have been made at least, or at least I've thought of methods in order to combat certain things, and I've avoided any major memory leaks which would be absolutely detrimental on performance. Now that is about everything I wanted to cover in this submission, so thank you for listening, and goodbye.